If you're new to the show, Open Tech Talks is your weekly sandbox for technology insights, experimentation, and inspiration, with the primary objective of learning and sharing. Well,
Welcome to the OTech Talks podcast, where it's all about working on technologies. You will hear the latest tech information, and your host, Kashif Manzoor, brings together product overviews, how-tos, best practices, tips and tricks, and troubleshooting techniques.
welcome to the new podcast series, which we have started to cover the fundamentals of Oracle Cloud Infrastructure. Today is our second session number 2, but overall podcast number is 84. And this is audio series to go through the essentials of Oracle Cloud Infrastructure. And if you're new to the show, just to welcome you. And if you're a regular listener, thank you so much for sharing your feedback. And just to repeat again that we have started 6 to 8 session series on the OCI to cover the basics. It's the concept behind, the idea behind is that if you're jogging, working out, or driving, so you can go through the basics of OCI. And you can refresh your knowledge, and so you don't need to be worried that you need to have some access to the internet or books to study it or to read it. That's on the ride, on the drive, on wherever, on the go. It can help you to support you, and even I'm also gonna do the same thing to learn it. Thank you so much. Now, just as a disclaimer, and that the opinion expressed or the knowledge expressed is from the standard Oracle documents, and this is based on experience, practice, and observation, and does not reflect basically or represents the thoughts, intentions, and plans or strategies of my current or previous employers and their clients and customers. All the information, the views expressed on this is blog and the podcast are my own and do not necessarily reflect the views of Oracle. That is just to make sure that these are personal passion to keep working and supporting each other on the knowledge and the understanding. So now we'll go to our second session on the OCI, and in the first session we have gone through the basics terms, then what is OCI, and not OCI, basically VCN, the networking component, and now we are going to cover the different gateways from a networking point of view, and the another important gateway is the dynamic routing gateway. It's called DRG, and it's an optional virtual router which can be added into the VCN. Now, what it does, it provides a path, a tunnel for private network traffic between your VCN and on-premise network. So you can use it and with other networking components and route it in your on-premise network to establish a connection between of your on-premise network to the Oracle VCN, and that you can all use the IPsec VPN Oracle Cloud Infrastructure Fast Connect. It provides a path for private network traffic between your VCN and another VCN in different region. Now, there are two ways to access the traffic of the VCN. If you want to have a secure traffic access to your on-premise network, and you want to treat it like an on-premise network. And these two ways are that you need to have a VPN Connect, which is basically offers IPsec tunnel between your existing network edge and your VCN. And then you use the way of DRG, dynamic routing gateway, that you can create and attach to your VCN. And or you can have a Oracle Cloud Infrastructure Fast Connect. It offers a private connection between your existing network edge and Oracle Cloud Infrastructure. and traffic basically does not traverse the internet. Both private peering and public peering are supported. This means that your on-premise host can have private access IP4 addresses to your VCN as well as regional public IP4 addresses in OCI. For example, object storage or public load balancers on your VCN. So that's how you can access to both types of connections between on-premise and on the Oracle Cloud Network. You can also have a connection to another cloud provider like Microsoft Azure, and Oracle and Microsoft have created a cross-cloud connection between Oracle Cloud Infrastructure and Microsoft Azure in certain regions. And this connection basically enables you to set up cross-cloud workloads without the traffic between the clouds growing over the internet. So you don't need to go to the internet, and then you can have a direct traffic between two data centers, Oracle data center and Microsoft Azure data center. That's how you can use the dynamic routing gateway. Now we will go to the next gateway, which is Internet Gateway. It's again another virtual router that you can add to your VCN for direct internet access. And if you want to access from the internet, example, the applications or database or anything you want to access from the internet, then you can use the Internet Gateway. And these are basically the virtual routers, Internet Gateway for resources with public IP addresses that need to be reached from the internet. For example, a web server, or need to initiate connections to the internet. So usually you go through the public IPs which you assigned on the instances, and you want access through the internet, then you will be using an Internet Gateway. And then there is another, when we talk about internet access, then there are two types of gateways. One is Internet Gateway, which has the public IP addresses, and it enables to reach to the internet, like a web server if you're putting on. And then there's another one which is a NAT Gateway. So now the NAT Gateway, what it does, it will not have a public IP addresses, but what you want to do, you want to initiate connections to the internet. From inside connection, from the instance connection, nobody you can access from the outside, but from the instance you want to access to the reach to the internet. Then you need to have a NAT gateway. For example, some patches, update, or something you need to download from external sources. Then you can have it's a protected layer, so you can have a NAT gateway to establish it. Now, to access public services, there's a tip on that one. To access public services such as object storage from your VCN without the traffic going over the internet, we use service gateway. And I think we'll go in a detail for the service gateway, because service gateway is an internal gateway to access to that one. So that's how we covered the NAT gateway. Now we will go to we covered DRG, Internet Gateway, then the network address translation, basically NAT gateway. And now we will talk about the service gateway. So it's another virtual router that can be added into your VCN, and it provides a path for private network traffic between your VCN and supported services in the Oracle Cloud Infrastructure. Now, for example, on the OCI object storage and autonomous database or DB systems in a private subnet, they need to have access to the object storage without going through the public internet. So for that, we are using which we're calling as the service gateway. Now the service gateway, from a conceptual network point of view, it's reserved for Oracle services. These services have public IP addresses that you typically reach over the internet, and but you want to access the Oracle services network without the traffic going over the internet. So there are different ways host in your on-premise network. So you can have a private access through a VCN with fast connect, private peering, or VPN connect. And the on-premise host uses private IP addresses and each Oracle Services network by way of VCN Service Gateway, or the public access. So a service gateway lets you your virtual cloud network privately access specific Oracle services without exposing the data to the public internet, and no internet gateway or NAT is required to reach those specific services. And these services are like object storage and file storage we were talking about. And the services in the VCN can be in a private subnet and use only private IP addresses. The traffic from the VCN to the Oracle services travel over the Oracle network fabric and never transfers the internet basically. The service gateway is original and enables access only to supported Oracle services in the same region as the VCN. The service gateway allows access to supported Oracle services within the region to protect your data from the internet. And the supported Oracle services, for example, object storage and other Oracle services. The service gateway lets it has set up a VCN so that you can access on-premise network, and it has a private access to that one. That's how you will be using a service gateway to access the private traffic within the Oracle in network, for example, from instance to the storage. Now let's spend some more time on the NAT gateway because it's important. NAT is a networking technique basically, and it's commonly used to give an entire private network access to the internet without assigning each host a public IP4 addresses. And the host can initiate connections to the internet and receive responses, but not receive inbound connections initiated from the internet. And when a host in the private network initiates an internet-bound connection, the NAT device's public IP addresses becomes the source IP addresses for the outbound traffic. The response traffic from the internet therefore uses the public IP addresses as the destination IP address. The NAT device then route the response to the host in a private network that initiated the connection. And there are some scenarios where, imagine you have the resources that need to receive inbound traffic from the internet, for example, web servers. You also have a private resources that need to be protected from the inbound traffic from the internet. All of these resources need to initiate connections to the internet to request like software updates from sites on the internet. So what you do, you set up a VCN and add a public subnet to hold the web servers. When launching the instances, you assign public IP addresses to them so they can receive inbound internet traffic. You also add a private subnet to hold the private instances. They cannot have a public IP addresses because they are in the private subnet. So you add an internet gateway to the VCN. You also add a route rule in the public subnet's route table that directs internet-bound traffic to the internet gateway. Now we will talk about these route tables and all that one in the next session. You basically add a NAT gateway to the VCN, and so there is important tip on that one, that a NAT gateway always can be used only by the resources in the gateway's own VCN. If the VCN is paired with another one, resources in the another VCN cannot access the NAT gateway. Also, resources in an on-premise network connected to the NAT gateway's VCN with fast connect or IPVC, IPVPN cannot use the NAT gateway. So the NAT gateway supports TCP, UDP, ICMP, ping traffic. The NAT gateway supports a maximum of approximately 20,000 concurrent connections to a single destination addresses and port. The networking service automatically assigns a public IP addresses to the NAT gateway. So you can't choose the public IP addresses or use one of your reserved public IP addresses. There's a limit on the number of NAT gateways per VCN. You can request increase to that limit basically. And routing for a NAT gateway, you can control routing in your VCN as the subnet level. So you can specify which subnets in your VCN use a NAT gateway. So all this you can manage it. And you can also have more than one NAT gateway. If you want to have internal application to destination traffic from the VCN's different subnets, you could set up a different NAT gateways. You can also block traffic through a NAT gateway. You create a NAT gateway in a context of specific VCN. In other words, a NAT gateway is automatically always attached to only one VCN of your choice. But you can block or allow traffic through the NAT gateway at any time. And by default, the gateway allows traffic upon creation. Blocking the NAT gateway prevents all the traffic from flowing, regardless of any existing, root roles or security rules are available in the. You can to delete a NAT gateway, traffic does not have to be blocked, but there must not be root table that lists as a target. So that's some of the more information on the NAT gateway. Now we will go to our next one. We covered DRG, Internet, NAT, Service Gateway. Let's talk about something on local peering gateway, because that's another concept in the VCN. The local peering gateway, which is within the region, basically. So local VCN peering is the process of connecting two VCNs in the same region. So we know VCNs, so VCN private virtual cloud network. So now if you want to connect two VCNs within the region, so you can use the VCN peering. And these resource can communicate using private IP addresses without routing the traffic over the internet or through your on-premise network. The VCNs can be in the same Oracle Cloud Infrastructure tenancy or different ones. Without peering, a given VCN would need an internet gateway or a public IP addresses, for instance, that need to communicate with another VCN. Now, then the components for peering is we need a high level. The networking service components required for a local peering. 1, 2 VCNs with non-overlapping CIDR in the same region. 2, a local peering gateway, LPG, which is called, on each VCN in the peering relationship. 3rd, a connection between those two local peering gateways. 4 is supporting route rules to enable traffic to flow over the connection, and only to and from select subnets in the respective VCNs. 5 is supporting the security rules to control the types of traffic flowed are allowed to and from the instances in the subnet that need to communicate with another VCN. So these are the 5 basic steps you need to enable the local peering, remote peering between two VCNs. And a VCN can use the peered local peering gateway to reach these resources, like, for example, VNX in the other VCN, an on-premise network attached to other VCN. If an advanced routing scenario called transit routing has been set up for the VCNs. So that's you can do in the remote peering network. Now, to enable these pairing, there's an explicit agreement is required from both the sides. As we know that pairing involves two VCNs, and these VCNs can be owned by different departments or parties. So both need to it's like a service provider model. Both need to agree on it. So pairing between two VCNs require explicit agreement from both the parties who are owning the VCNs, and it need to be identity and access management policies that each party implement for their own VCN's compartment tenancy. If the VCNs are in different tenancies, each administrator must provide their tenancy OSID, like the Oracle IT, the unique ID, and put in place special policy statements to enable the pairing. Then there is another scenario for the local pairing, that's transit routing, and this is very common nowadays. Within the concept of transit routing, that where what you do is it's called a transit routing that enables communication between on-premise network and multiple VCNs over a single fast connect or IPsec VPN. And the VCN must be in the same region and locally peered in a hub and spoke layout, basically. So as part of this scenario, the VCN that is acting as the hub has a route table associated with each local peering gateway. Typically, route tables are associated with VCN subnets. So when you create an LPG, you optionally associate a route table with it. Or if you already have an existing LPG without a route table, you can associate a route table with it. The route table must belong to the LPG's VCN. And then pairing, if you're new to the pairing, a pairing is a single pairing relationship between two VCNs. If VCN 1 is paired with 3 other VCNs, then there are 3 pairings. The local part of the local pairing indicates that the VCNs are in the same region. A given VCN can have a maximum of 10 local pairings at a time. And the 2 VCNs in the pairing relationship must not have overlapping CIDRs. That's very important. However, if the VCN 1 is paired with other 3 VCNs, those 3 VCNs can have overlapping CIDRs with each other. You would set up the subnets in VCN 1 to have route rules that direct traffic to the targeted paired VCNs. Then you can also have, pairing administrators which can agree practices, share the information with each other, acceptor and requester. You can enable the, IAM policies, basically identity and access management policies. The local pairing gateway is a component which is on VCN for routing traffic to locally paired VCNs. So all these are the basic concepts for the local pairing gateway within the region. That's what we cover now. Now we will go and we will cover the remote pairing. We earlier covered local VCN pairing within the region. Now the next topic is remote VCN pairing across region. So basically the remote VCN pairing is the process of connecting 2 VCNs in different regions, however within the same tenancy. And this pairing allows the VCN's resources to communicate using private IP addresses without, routing the traffic over the internet or through your on-premise network. Without pairing, a given VCN would need an internet gateway and public IP addresses in the instance that need to communicate with another VCN. So, for example, you have one region and another region, and then you have 2 VCNs. Now, definitely, if you want to connect them, then you need to route them to the internet traffic. So that's what is remote VCN pairing across the regions. At high level, again, there are 6 steps to, from a remote pairing point of view. You need to have 2 VCNs with non-overlapping CIDRs in different regions that support remote pairing. But it's make sure that VCNs must be in the same tenancy. And these VCN CIDRs must not overlap. That's also an important point. And then a dynamic routing gateway, a DRG attached to each VCN in the pairing relationship. And your VCN, already has a DRG if you're using IPsec VPN or Fast Connect. A remote pairing connection, RPC, on each DRG in the pairing relationship. And that's the fourth step is a connection between those 2 RPCs, remote pairing connection. Supporting route rule to enable traffic to flow over the connections, like only to and from select subnets in the respective VCNs. And then you need to also have security rules to control the types of traffic flow allowed to and from the instances. And it's then there's another famous one is spoke to spoke remote pairing with the transit routing in that one. Now in this scenario that for example in each region you have multiple VCNs in a hub and spoke layout, and this type of layout within a region is this it's being recommended or use it, then what you do is you use the spoke VCNs in a given region or locally and paired with the hub VCN in the same region using local pairing gateways. So you can set up remote pairing between the 2 hub VCNs. You can also then also set up a transit routing for the hub VCNs DRG and LPGs. And this setup allows a spoke VCN in one region to communicate within one or more spoke VCNs in another region without needing a remote pairing connection directly between 2 VCNs. And again, the explicit agreement required from both sides, similar to local peering gateway, that both peering involves two VCNs, same tenancy, must be administrated, must be own compartments. Again, peering is a single relationship. Then we need to have a VCN administrators. They same basic information with each other, acceptors and requesters. Then region subscriptions, remote peering connection, RPC. All these are the basics, basically setup steps to achieve the remote peering across the regions. So I think with this we will finish our today's second session, where we covered, if we will summarize our till now, what we did is, in the first session we covered what is VCN, then how subnets divided, VNets, private IP addresses. Then in the second session we covered the DRG, the different gateways, internet gateway, network, NAT gateway, service gateway, local peering, remote peering connections, how these are established. And with these, I think the basic concepts, you are almost done with the core concepts of establishing a VCN or a network on OCI. And in the next session tomorrow, that's will be a third session of that one, we will go in a more detail on the, basically, for the route table, what is route table, security list, DHCP options. So all these are our for example, again, essentials. That okay, what are the default components? So that we will do it tomorrow in the third session, basically, after the interview, because each and every what we are creating is covered with the route table, security lists, and all the default components. So thank you so much for listening and spending time on this podcast to go through the basic concepts of VCN, Oracle OCI, Oracle Cloud Infrastructure. That's again learning and sharing with each other. Please do share your feedback on iTunes or comments, and we'll talk to you soon. Thank you. Bye-bye. See you soon. Thank you. Bye-bye.
Thanks for listening to the OTech Talks podcast, and be part of Tech Talks at otechtalks.tv. It's a turf to share ideas, insights, and innovations.